In this video, we'll look at some example problems related to vector operations in R3. Specifically, we'll calculate a dot product of two vectors in R3, and we'll determine how to find the normal vector to a plane. Here we need to compute the dot product of the vectors s and t in R3. To help us compute that, let's visualize what these vectors look like in R3. So here we have a representation of our two vectors, t and s, depicted in R3. Here we have the y-axis, the x-axis, and the z-axis. So here we have our two vectors, and we want to look at what the dot product of these two vectors is going to be. So if we look at our vector s dotted with our vector t, well, that'll be x1 times x2 plus y1 times y2 plus z1 times z2. And you can extend this dot product to any n-dimensional vectors. So now here we have, x1, 3 times 1 plus y1 times y2 is going to be a negative 1 times 2 plus z1, which is 4 times 0. So we'll get 3 minus 2 plus 0. So our dot product here is 1. Now we could have used the other representation of dot products using the distance of these two vectors and the angle between them, but it would have been more difficult to determine what the angle between these two vectors are. Here we're trying to find the vector n that's normal to the plane created between the vectors a and b. So if we take a second to visualize what this looks like, well, here I have my vectors a and b, and the plane that's created between them is going to look something like this. So that's the plane created between them, and then we get a vector that's normal or creates a 90 degrees with that plane depicted there. And there are two options. The vector could be going in the opposite direction, but we use something called the right-hand rule. So if you'll notice down here at the bottom, this hand, that helps us determine which direction a cross b, or my normal vector, should be. So you take your pointer finger and your middle finger, and that creates your two vectors a and b. You line those up, and the direction that your thumb is pointing, that will be the direction in which your normal vector a cross b is supposed to go. So if we return now to calculate the vector, here I have the formula for the vector over here. So n will equal a cross b defined by this formula. So now if I want to compute this, well, n will equal, here we have y1, which is going to be 2 times z2, which is 1, minus z1, so z1 is 1, times y2, which is negative 2. So that will be my x component. And now I take z1, so that's 1, times x2, so the x component for my b vector, which is 1, subtract x1, which is, in this case, is 0, times z2, which is 1, and then x1, which again is our 0 component, times y2, which is negative 2, minus y1, which is 2 times 1. So if we simplify this out, we get 4, 1, negative 2. Now here we have a vector that's normal to the plane created between the vectors a and b.